All right, section 6.2. This whole chapter, I don't think I said this yesterday, but this whole chapter is about quadrilaterals. Okay, and basically, what is a quadrilateral? It's what? Four, right? Four sides. Okay, so it's a polygon with four sides. This is a real specific type of parallelogram, and we're going to do a lot of stuff. I just gave it away. Quadrilateral. It's a very specific type of quadrilateral, and it's called, guess what? A parallelogram. All right, so it's parallel. All right, that's how you spell parallel. Two L's first, then one L. Everybody see that? All right, everybody watching? We started. All right, so we spell parallel like this. Two L's, then one L, and then ogram. All right, so it's a parallelogram. Pretty easy. And let's basically give you a shape of a parallelogram. It kind of looks like this. That technically is a parallelogram, but this is what we see more often than not. How do I do this? Is it shear? Did it click? Oh, there, it's just a little slow today. Let's go like 20 degrees. Let's preview that. Yep, that's what I wanted to do. Okay, so that's kind of what your average looking parallelogram is when you see this in a book. All right, there's other different, like when I first did it, it kind of looked like a rectangle. We're going to learn this a little bit later in the chapter, but a rectangle is also a parallelogram. Actually, we might even learn that today. I think so. All right, but there's things we need to learn. So I would keep a list of these things because this is very important. We're going to learn a lot of stuff about a parallelogram. The first thing we're going to learn is let's use the definition right here. So the definition of a parallelogram. It's a quadrilateral. So here, watch. I'm gonna have a list of like four or five different things right here. The first one is by definition. You're not gonna have to like memorize words for a definition, but this is basically the definition of a parallelogram. It's a quadrilateral, so you got four sides that has both pairs of opposite sides parallel to each other. Writing all this down? Getting this down? Is it up here? Is that what it is? Sure it is. Write it down. Get some paper out and write it down. Watch. Both pairs of opposite sides are parallel to each other. So that means that's one opposite pair of sides, so they're parallel. And then there's two pairs of opposite sides. So those are parallel. That side is parallel to this side right here. All right, so that's by definition that both pairs of opposite sides are parallel. Let's label this, make this a little easier for us. So by definition, what's true? AB, line segment AB, is parallel to line segment DC. All right, and what else? AD is also parallel to what else? BC. All right, so we'll just write it like that. Okay, so both pairs of opposite sides are parallel. That's the definition of parallelogram. Everybody understand that? It's pretty easy, right? So this side and this side are parallel, and these two sides, the two opposite sides, are parallel to each other. If you can remember that, then that's basically the definition of a parallelogram. All right, and that's pretty important information, and we're going to use that quite a bit as we go on. Now, that's the definition. The rest of these are theorems. And if you want to write, I'll just put theorem right here. So the rest of these are different theorems, and I'm just going to mark them, and we're just going to kind of do what we've done right here and just show you what sides are equal to each other, what angles are equal to each other, and all that kind of stuff. So by definition, the opposite sides are parallel. Now we have a theorem that says the opposite sides of a parallelogram. So if you have a parallelogram, so we've already defined it. We've already said this is a parallelogram. If it's a parallelogram, then the opposite sides are also, what does a little tick mark mean? They're equal to each other. They're congruent to each other. So they're parallel and congruent to each other if it's a parallelogram. So these two sides are equal to each other in length. So if I measured AB and DC, they would be exactly the same length. And same thing with AD and BC. So let's write that down. So we could say that AB is equal to, the length of AB is equal to the length of DC. We can also say that AD is equal to BC. The reason I didn't put a line segment over top of it because I'm talking about the measure, the length of. When I talk about the measure or the length of it, I don't put a line segment over top of it. I just say that the measurements are equal to each other. Now, if you look in the book, they put a little line segment over top, but they say the word congruent right here. It's the same exact thing. I just kind of like to write it. I kind of like writing it like this better. All right, we good with that? That's pretty easy, isn't it? So if I told you this was a parallelogram, that means these two opposite sides are equal and these two opposite sides are equal to each other. We good? All right, there's another thing that's true. about this if it's a parallelogram. Let's talk about the angles this time. Look at angle A. Now, does angle A look like it's equal to angle D? Nah, because that's obtuse and that's acute. There's no way. But what do you think? A and C. That's absolutely right. So A and C are equal to each other. And what else do you think? Angle D and angle B would be equal to each other. So what we say is we say that the opposite angles of a parallelogram are equal to each other. So I have to start off understanding that I have a parallelogram. So if I have a parallelogram, then that means the opposite angles are equal. So if I knew this was 120 degrees, I don't have to do any math at all. I could figure out that that's 120 degrees. Everybody see that? Pretty easy. So let's write that down. So angle A equals angle C, and angle D, oops, let's try that again. Angle D is equal to angle B. Doesn't matter what order you put those in. All right, so the opposite angles are equal to each other on a parallelogram. So again, if I told you this is a parallelogram, I could automatically see that these two would be equal and these two would be equal. And that's a theorem. Theorem can be proven. I don't believe we're going to prove these right yet, but it can be proven. Okay, what's the fourth thing? Now watch. These things, this is kind of a little proof. This is parallel to this right here. This would be a transversal. Tell me something about this angle here, A, and this angle, D. We learned this in another chapter. What's the name of them? They're not corresponding. What are they? Well, they are supplementary, but what's the name of the angles? They're consecutive interior angles. That's right. They're consecutive interior angles. Remember that? Now you can say, what's true about consecutive interior angles to parallel lines? They're supplementary, okay? So this and this are supplementary. So what we can say is that we call these the consecutive angles, right? These are consecutive angles because they're right next to each other. So the angles that are right next to each other, A and D, A and B as well, right? They're consecutive interior angles. So they would be supplementary. So let's do this. Let's say angle A, I'll just write it like this, is supplementary to what? Angle D and what else? Angle D and B. A and C are equal to each other, but it's supplementary to B, isn't it? You with me on that? So angle A is supplementary to D. Angle A is supplementary to B. All right. What else can you say? We could say angle. Yeah, let's do this. Let's go angle D and say that it's supplementary. What's angle D supplementary to? Well, we already said up here it's supplementary to A, right? But it's also supplementary to C. So we'll put and. And you could do other combinations as well, but they'll all boil down to one of these combinations right here. All right, so A and D are supplementary. What does that mean? It means they do what? They add up to 180. So if this was 120 degrees, what would you tell me angle D was? 60. All right, so I could find all those angles if I just knew one of them, couldn't I? If that's 120, that's 60. What's this one right here? That's 120, and this would be 60 right here. Pretty easy, isn't it? All right, it's not hard, and it's not hard to see. You know, to know that this side is equal to this side. You just have to know it to begin with. If you already know it, then it's easy to do the math. Let's see. Let's do another picture here. Watch this. Do you think this would be considered a parallelogram? Yeah, because those two sides look parallel to each other, right? And these two sides are parallel. So yeah, that's a parallelogram. But watch this. I kind of drew it. I didn't kind of drew it. I exactly drew it so that I had a right angle. So if this was a right angle, let's do our math up here according to the stuff we just talked about. If this is a right angle, tell me what this one right here is. Why? Give me a reason. Because they're consecutive interior angles, right? Because this is parallel to this. Consecutive interior angles are supplementary, so that's 180. Okay, I know, but I want to go give a reason for each of them, okay? So watch, if this angle is 90, this has to be 90 from what we've talked about up here, right here, right? It's supplementary to this consecutive angle. What about this angle and this angle right here? They're equal to each other because they're opposite angles. So this angle is equal to this angle. You follow me? What about this angle down here? It's the same one as that, or it's supplementary to this. So if I only know one of them is a right angle, guess what? All four of them are going to be right angles, okay? So if one's a right angle, and we haven't really discussed this yet, and I don't think they talk about this until another lesson. Let me just take a quick peek here. I don't think they do.
Does every angle in a parallelogram add to 360?
Yeah, because it's a quadrilateral. Any quadrilateral doesn't matter what the shape of the quadrilateral is. Every quadrilateral, all the angles will add up to 360. And that's a good point. Look at this. 120 and 60 is what? 180. That's 120 and 60. That's another 180. What do they add up to? 360. And they have to. If they don't add up to 360, you did something wrong. Right? So anytime you have a four-sided figure, it doesn't matter how weird looking the four-sided figure is. All right? It could look like this. Okay, all four of these angles inside of here have to add up to 360 degrees. We talked about that yesterday. Remember that? Okay, but this is a little bit more specific. Let's get rid of all. Oh. Okay, now I get rid of it. This is more of a specific type of quadrilateral. All right, it's specific because it's four sides, yeah. But what's true about the opposite sides? The opposite sides are parallel to each other. So if the opposite sides are parallel, that means the opposite sides are equal, and the opposite angles are equal to each other. Okay? Yes?
Can a diamond be a parallelogram?
I guess it depends on the shape of the diamond. You could have... It depends on the shape of the diamond. Let's do this. Let's copy this. Let's make this a little smaller, like that. And if all these sides were equal to each other and we took it, I guess you could consider that to be a diamond, right? Looks like a baseball diamond. So what I did is I took a square, basically, right? And I just rotated, and it kind of looks like a diamond. But what if I did this? Well, that's not going to... Let's see if that works. Yeah, I think the only way that it can be a parallelogram on this diamond is if it... Listen to me, please. The only way that it could be a parallelogram, it looks like if it was a square and you just rotate it, and it could be a diamond. But like if you just... Let me think. So if you drew a diamond like this, right? And then you went down like that, are the opposite sides parallel to each other? Okay, is that in that parallel, or I don't know. Well, let's see. Probably not. I don't know. Could you make it? Could you make a diamond and have these? But what has to be true about a parallelogram also? The opposite sides have to be what? Equal to each other. So is that side going to be equal to that side? No, it's not. Okay, so these will not be parallel. I don't think you could make it unless it was a square. You could make these actually parallel to each other. Okay, does that make sense? All right. Okay, enough of that. Let's move on to one more thing. We'll do this in the next video and then we'll quit. Actually, I think I can fit this in this video. Okay, here's one more thing. Let's do this in another color. What we're going to do, we talked yesterday about diagonals. What we're going to do here is we're going to draw a couple diagonals, but not from the same vertex, okay? We're going to draw from here to here, right? And then we're going to draw from this vertex up here to this opposite one. So I've got two diagonals. What looks true? Does it look like those diagonals are equal to each other? Now, that one definitely looks way shorter than that one right there, doesn't it? Okay? But they do intersect each other, and what do you think about that point of intersection right there? Look at this side. We'll go A, B, C, D. And we'll go P for point. Okay, so watch. Look at AP and look at PC. Just by your eye, what does it look like might be true about those? Okay, P is the midpoint of AC. That's right. And P is also what? The midpoint of DB. All right, so that means AP and PC are equal, and DP and PB are equal to each other. Everybody see that? That means these diagonals bisect each other, and that's what our it's another theorem, and it says the diagonals of a parallelogram bisect. The diagonals bisect each other. Okay? So the diagonals bisect each other on a parallelogram. That's important too, because again, you see what they're going to do with this, don't you? They're going to give, this is like x plus 2, and this is 3x minus 5 or something, and what do? You set them equal to each other, and you solve for x and all that good stuff. All right, let's give you your assignments. Okay, there it is, page 403, 9 to 12, 15 to 20.